Hello, my name is Akshay Shiore and I'm an application engineer at MSc Software. Today I'm going to discuss how one can easily and effectively create vehicle suspension designs that can be used to help make design decisions at the initial concept stage up to and including detailed analysis with the complete vehicle. A vehicle suspension design process is a multi-step process involving choosing the appropriate vehicle configuration and carrying out detailed analysis for ride, handling, and component loads. It is imperative that the model provide accurate and consistent metrics on a repetitive basis so that design trade-offs can be correctly studied. Once a model is built, it is shared amongst various groups in charge of different attributes like handling, ride comfort, and durability. MSc Software's MD Adams car package provides a single environment where engineers can iterate and choose appropriate vehicle suspension configurations and then analyze and tune it as they would with a physical prototype. Adams car has templates which capture generic configurations typically used in automotive suspensions, as well as test methods and procedures exercised on physical prototypes. Adams car separates data and form. Thus the same template and the different components, i.e. data, can be effectively used across different vehicle programs. Adams car also outputs appropriate vehicle metrics in line with standard automotive testing processes. It thus eases exchange of data amongst different departments and helps in sharing of common data, properties, and results. At the start of a vehicle program, Adams car helps the engineer analyze different suspension configurations first. For example, the engineer can compare metrics between, say, a double wishbone and a McPherson strut type front suspension. Once a particular choice meets initial metrics, a detailed design optimization for bushings and hardpoint locations is carried out. Once an optimum suspension is chosen, the engineer then creates a full vehicle model with that suspension. Full vehicle ride and handling analyses like lane change and constant radius cornering is now carried out to look at metrics like yaw rate, chassis roll, steering wheel angles, etc. The engineer in the ride group next uses the handling model as a starting point and changes to higher fidelity components to see how they affect the simulation results. Adams car provides detailed bushing and damper models for such ride analyses. At this point, the model would consist of rigid parts. The engineer in charge of durability, on the other hand, needs to include flexibility of the suspension components and run on rough roads to look at component loads, hot spots, and stresses. Again, Adams car provides the ability to swap the rigid components with flexible ones and carry out durability events like a 4-post shaker test, straight line drive over rough roads, etc. This was just a quick overview of a general automotive suspension design cycle. Adams car provides additional utilities like a road builder and tire and component test rigs to facilitate test data input. It also provides a virtual driver interface and an event builder to create custom events, just like testing procedure specs provided to test drivers on vehicle proving grounds. Thanks for watching. If you'd like to learn more about how Adams car can help you design vehicles faster and easier, visit www.mscsoftware.com.
Accurate wheel alignment does not last the life of your car. In fact, you could leave our facility today, and an innocent hit to a curb or unavoidable pothole can cause a sudden and sometimes dramatic change in alignment. Regardless of this type of impact, wheel alignment is always changing. A considerable shift in the alignment can occur in only 18 months. But because these changes are small and occur slowly over time, it's easy for certain handling problems and tire wear conditions to become firmly established. Let's take a look at what's happening. Joints and bushings in the suspension system wear gradually, which makes it more difficult to hold the alignment in place. Camber and caster both begin to change. The same thing happens with the steering system. Normal wear and tear takes its toll, and toe begins to change. And let's not forget about the rear of the car. The same slow decay is occurring there as well. The springs are wearing out too, and as the springs give way, so goes the alignment. Even though this type of wear is very slow, eventually certain parts may require replacement before the alignment can be done. Rapid changes in alignment are usually caused by impact or collision damage. The type of impact that will bend or move parts. For example, a control arm, a tie rod assembly, or even a shift in the position of the suspension in the chassis. Of course, damaged parts will require replacement. The alignment condition of your car is always changing. And because these changes are small and occur slowly over time, it's easy for handling problems and tire wear conditions to become firmly established. If you're currently experiencing any of these symptoms, get your alignment checked immediately. Otherwise, to prevent these problems from occurring, get your alignment checked at regular intervals. Check with our service department to see which plan is best for your car.